This video is on quadratic inequalities. Let's look at example 1. Solve x squared plus x minus 6 is greater than 0. And b, x squared plus x minus 6 is less than 0. So what we're going to need to do here is we're going to need to try and treat this question similar to the quadratic equation questions from National 5. So we'll start by letting x squared plus x minus 6 equal 0. This puts it in the form that we're familiar with. So at this point here, you don't need to bring things over to the right hand side. When you're solving a quadratic equation, you want to have everything on the left hand side to be able to factorise. There's no common factor, there's no difference of two squares, so it's a trinomial factorisation. Now there's many different methods to do this. You want the numbers to multiply to give you 6, so it's going to be 3 and 2. But you want them to add to give you plus x, so plus 1x. So the options you have are positive 3 and minus 2, minus 3 and positive 2, because you're looking for negative 6. But you want plus x, so it's going to be x plus 3, x minus 2 equals 0. Feel free to show any of the working that you're familiar with for that type of factorising. Now, you've got x plus 3 and x minus 2, so you're going to get two solutions, x equals minus 3 and x equals 2. And those are your roots on a graph, and we're going to be drawing a graph in a second to help us with the inequality. In National 5, you would have stopped here, but because there's a greater than and a less than sign, the question is slightly different. So we draw a graph with our y and x axis. We then want to put in our roots. We have negative 3, which will go roughly around here, and we have 2, which would go roughly around here. It does not need to be perfect. You know that it's a positive x squared, so it's going to have a minimum turning point, and you draw in the graph as best you can. And we've got that there. Now what we want to do is we want to work out, well, what happens when it is greater than 0, i.e. above the x line here. So what we're going to do is we're going to circle the areas above the x-axis. So I'm going to circle this region here, and I'm going to circle this region here. And those are the two parts where this graph is above 0. Therefore, I have two range of values that I could have here. The answer is going to be when x is less than minus 3, because if you look at the graph, I've circled this region here, and these numbers on the x-axis would be less than minus 3. You would get minus 4, minus 5, minus 6, etc. And the second region of the graph over here that we've circled, well, that's when x is starting to get bigger than 2. So that's going to be x is greater than 2. And that would be your answers for the first quadratic inequality there. So this is your answer to question A. So when x squared plus x minus 6 is greater than 0, we know that x is less than negative 3 and x is greater than 2. So it's going to be one or the other. But you write both answers in for a quadratic inequality. If you look at B, the only thing that's changed there is it is now a less than sign. So again, we can have the same diagram. So if I draw it quickly, I have minus 3 here, and I have 2 roughly around here. I draw the graph, and then this time, I want the region where it's less than 0. And you'll notice that there's one continuous sort of region here where it is less than 0, i.e. below the x line. And how I would write this is, I would write, well, it's between minus 3 and 2, and the way we write that is minus 3 is less than x is less than 2. And basically it's one continuous region, that's why they are together. So you are saying that x is going to lie between minus 3 and 2, and that is your quadratic inequality for x squared plus x minus 6 is less than 0. Let's have a look at example 2 then. Solve 4x minus x squared is less than 0. So again we start the question in the exact same way. We let it equal 0. So 4x minus x squared equals 0. I factorise it. It's not a trinomial this time in terms of the three terms, what we have here is a common factor. You always check for a common factor first. Our common factor is x, so we take x out, and that gives me 4 subtract x inside the brackets. That gives me two solutions, x equals 0 and 4 minus x equals 0, giving me x equals 4. Now again, what I'm going to do is I'm going to draw a diagram to represent this. However, there's one key difference, and it is with this negative here. You have a negative x squared, and that has an impact on our graph. So let's have a look at the next slide. If you have got a negative x squared, you should know from National 5 that that means you have a maximum turning point. And a maximum turning point is the other way round and slightly different from the minimum turning point. Basically, in very, very simple terms, a minimum turning point is a bit like a smiley face, and a maximum turning point is a bit like a sad face, facing down the way. Your maximum turning point would be at this point here. You know that you have got the values of x equals 4 and x equals 0, 0 here in the origin. You want to know when it is less than 0. The question was asking you when is it less than 0. So what we do is we take our graph and we highlight the point when it is less than 0. That means it's below the x-axis. It's going to be below the x-axis in this region here and in this region here. So how we write that answer? Well, in this first region here, it is when x is a number before 0. So that means we can say x is less than 0. This region here is when the numbers start to go after 4. So then we can say that x is greater than 4. If the question was asking us for when it was greater than 0, we would highlight the region above the graph. But because it's asked for less than 0, it would be the region below. We have two separate circles drawn, therefore we need two separate ranges given. Because it is before 0, that means it's x is less than 0, and because the bit after 4 there is going to be x is greater than 4. And that is how you solve a quadratic inequality.